Welcome, Algebra. We are working on section 8.5 today. And the cool thing about section 8.5 is at the beginning of every lesson, you guys want to ask when we're going to use this. And I can say with absolute efficiency that you need to be able to know scientific notation, and you've already seen it before. And my example is very simple. I go to a calculator and I want to type in a big number. Let's say there's a bunch of zeros. Looks superior to 18 million. And we're going to multiply that times 925, 9,250,000. Two big numbers multiplied together. And then I push enter on my calculator and boom, right there, that thing is scientific notation. And that's exactly why we have to learn it. So if we move back into our problems here, scientific notation is always going to be written like this. Okay? There will always be only one number before the decimal. And the exponent determines the direction we move. So what we do to figure out what this is, because this is scientific notation, to figure out this number in regular notation, we would take down the 2.3 and we write it down here. We look and say to ourselves, okay, this is a positive 3. Positive numbers go to the right. We take the decimal place and we move it 3 times. 1, 2, 3. And we insert a 0. And so 2.3 times 10 to the third is 2,300. So if we had, I'll write over here, 2.3 times 10 to the negative third, we would take the 2.3 and we would move it to, because it's a negative, we would move it to the left. 1, 2, 3. We put the decimal there, we insert 2 zeros, and we're left with 0.0023. So, shortcut information is positive numbers make big numbers. Okay, positive exponents, big numbers. Negative exponents, small numbers. Okay, and the reason why this works is because this x here means multiplying, and I'm going to see a couple people say, well, we're not supposed to use an x. You can do a dot. That's perfectly fine, 2.3 times 10 to the third, but this is a scientific idea, so they will usually use the x. Now, the reason why it works is pretty simple. 10 to the third is just 1,000, and 2.3 times 1,000 is just moving the decimal place 3 times for the 3 zeros. And 2.3 times this would be 2.3 divided by 1,000, which means you'd move the decimal 3 to the left. So it's just a nice fancy way to write it, but it's not anything new. So let's look at some examples here. I want you to turn these into regular notation. So I take the number here and I rewrite it and I go 2.83. Because this is a positive exponent, I'm going to be moving to the right. So I move 1, 2, 3, I insert a 0, and I get 2,830. And that's my answer. Down here at the bottom, I rewrite this as 4.22. This is a negative exponent, so I'm going to move 4 to the left. And I get 1, 2, 3, 4. Put the decimal here. And my answer is, whoops, I hit the over button quite a bit there. And my answer ends up being 0.000422. And that's exactly why we don't write these in regular notation very often, because the scientific notation looks so much better than 0.000422, which is very difficult to deal with. So the 8.3, we'd move it 5 to the left. 1, 2, 3, 4, 5. Place the decimal there. 0.000083. So there's our answers. Now, one thing I want to point out real quick, on our calculator, this E here, that stands for times 10 to the. So if you'd write this on your calculator to check your work, you could go 8.3 times 10 raised to the negative 5, and it'll give you back that. Okay, but if you wrote 8.3 e is right here to the negative 5, it gives you the same thing. Okay, so the e and the times 10 to the mean the same thing on your calculator. Just remember that when you see it, it means scientific notation. Okay, I want you to pause and try these on your own. All right, so we're back. It shouldn't be too bad. The top one is 423 with 4 zeros. The second one here is 0.00010002. And the third one is 123 with 6 zeros, which would be 123 million. All right, if you have answers, ask me. I'm sure I'm wandering around the classroom somewhere. Okay, now we have to turn these numbers into scientific notation, which seems like it's a lot more difficult than it actually is. So, if we went back to that first slide, the very first thing I told you was, in scientific notation, you can have only one number before the decimal. Okay, so if we go here, we have to find the first number on the left that's not a 0, and we have to put a decimal place behind it. So I look here, and the first number on the left that's not a 0 is this 3. So I'm going to place this decimal between the 3 and the 4. And I'm going to go 1, 2, 3, 4, and end up at the very end. So I know that this is 3.4, because the other zeros can be ignored, times 10. And now I have to ask myself if this is going to be a 4 or a negative 4. And my justification is, let's look at the first number, that 34,000. Is that a big number or is that a small number? It's a big number. Big numbers need positive exponents. Therefore, this will be 3.4 times 10 to the positive 4th. Now we go down here. We got to find the first non-zero number on the left. So that's the 2. We place the decimal place right behind it. So we have 2.34. We'll write that down right away. And we go to the other decimal. So we go 1, 2, 3, 4. Now this time, because this original number was small, 8.000 was a small number, this would have to be a negative 4. And finally, the last one, this gets a little tricky. We go to the first number on the left and we find it, and it's a 1. So we have to put a point here, and I'm going to add a 0 behind the 1. So I can write 1.0. You don't have to, but I feel like that's easiest. And now I match it up with the other decimal. 1, 2, 3, 4, 5, 6. So this is 1.0 times 10 to the negative 6. Okay? Remember, positive exponents, big numbers. Negative exponents, small numbers. So I want you to pause this one and try it on your own. All right. See how we did. So this one should be 1.8 times 10 to the 6th. This one should be 2.45 times 10 to the negative 5th. And this should be 1.0 or 1 times 10 to the negative 3rd. Okay, if you have questions, ask me. I'm sure I'm just wondering. I'll see how we're doing for time. We're doing okay. Not great, but okay. So let's finish up strong. These are properties of scientific notation where we have to use what we've learned about exponents and what we learned about scientific notation to solve a number. So, top problem, we are multiplying these two numbers together. Scientific notation gives us a really, really cool shortcut. If we multiply these numbers here, 1.4 times 7.6, we get 10.64. And now I can, because we did that, times that, gave us that. And then I go times 10, and because we're being multiplied, we have to step down from multiplication to addition. And I get 10 to the 4th, and 10 to the 3rd becomes 10 to the 7th. And look at that. Now, the problem with this, though, is that if we look at the original number, we have more than one number or right here. The decimal place should be 1.064. But we can't do that. We can't just simply move it there. So we have to go 10.64 and change it into regular notation. So we go 1, 2, 3, 4, 5, 6, 7. So there should be 5 zeros here. And so I have 1064 with 5 zeros. And I have to place the decimal there and figure out what the scientific notation should be. So I go 1, 2, 3, 4, 5, 6, 7, 8. So I get 1.064 times 10 to the 8th. The other way to think of this, and sometimes the shortcut works, is if I want to move the decimal place from here to here, okay, I need to make the number bigger, okay, because 10.64 is bigger than 1.064. Therefore, I have to add 1 on the exponent. That's a little tricky, and I would recommend just doing it this way. Turn it into regular notation, and then back into scientific, and then it's not too bad. Okay, this one here, there are 2 ways to solve it. The first way would just be what we did here. Match up these 2 numbers. 1.2 divided by 4.8 is 1/4 or 0.25. Then we go times 10, and now we have to go -1 minus a -4, which will be +3. The other way that you could solve this would be because these are negatives, we can send this one from Vermillion to Brookings and send this one from Brookings to Vermillion. So we could go 4.8 times 10 to the 4th over 1.2 times 10 to the 1st, and then solve from there. And then you'll actually end up getting the same answer. But actually, that does not work. Don't do that. I'm not sure why it doesn't work, but that doesn't work. Don't do that. Do it this way. Okay? So now, once again, we have to turn this into regular notation. So we go 0.25. And it's 10 to the 3rd, so I go 1, 2, 3. So I get 250. And to turn it back into scientific, I go here, and I go 1, 2. So it's 2.5, because we can ignore that 0, times 10 to the 2nd. And the last one, okay, we distribute this 3 into all the terms. So the 3 goes to the 4, which is 64. Times 10 to the -6. So I do 64 and I go 1, 2, 3, 4, 5, 6. So I get 0.00064. The decimal place should be there. So I go 1, 2, 3, 4, 5. So I get 6.4 times 10 to the -5th. Alrighty, so try these on your own. Okay, let's finish up quick, and then we can get you the assignment. So I get 2.3 times 1.8, 4.14. Add the exponents together. 4.14 times 10 to the 8th. This one on the bottom, we get 5.2 divided by 1.3, which is 4. Nice. Or 4.0 times 10. We subtract the exponents to the 2nd. Last one, this becomes 25 times 10 to the -8th. So that would be 2.5 to the -7th. I'm almost positive on that. Yep. 2.5 times 10 to the 7th. Alrighty, you have questions, ask me. Here's your assignment. We ran a little bit over time. Top one are 5 problems 4, so 9, 13, 14, 16 problems. So I want you to get 13 right to move on. And the bottom, 4, 6, 8, 9, 10, 11, 12, 13. So I want you to get 11 right. Alrighty, good luck.